Hello students, in this video we are going to see all the important formulas for integration. Okay, so let us start with the algebraic function. So integration of 1 dx is equal to x plus c. Why it is like this? Because you can consider integration as opposite of differentiation. So when you differentiate x, it will be 1. Differentiation of constant is going to be 0, right? So we are adding constant cc in each of this because it's an indefinite integration. We will also see how to evaluate definite integration. Okay, first it is very important to remember these formulas. If you want to solve questions in physics, you must remember these formulas because we are not going to derive these formulas. We have to use this, we have to apply it in solving the problems. Okay, so this integration of 1 means it's just integration of dx. You can say integration of dx is equal to x integration k dx. K is a constant, k comes out, so integration of dx is x, so k into x plus c. X to power n, this I hope you remember, x to power n plus 1 by n plus 1, right? This we are going to use anyway. 1 by x integration ln x, because ln x differentiation is 1 by x. Similarly 1 by root x integration is 2 root x, right? Okay, then let's go to the next. Inverse trigonometric functions. In inverse trigonometric functions, okay, sine inverse x plus root under 1 minus x square. Cos inverse x is equal to x cos inverse x minus root under 1 minus x square. Tan inverse x integration with respect to x is x tan inverse x minus half ln 1 plus x square whole plus constant of integration. Cosecant inverse x, okay, so x cosecant inverse x plus ln x plus root under x square minus 1 plus c. Secant inverse x dx x secant inverse x minus ln x plus root under x square minus 1. Cot inverse x cot inverse x plus half ln 1 plus x square. You may say that why all these formula I have to remember. We don't know when it will be used, but mostly basic formulas will be used. Maybe inverse function will be not much used in physics, but still you need to know, and to remember better you write these formulas again or make a list and keep it in front of you, right, so that you can always remember it. Trigonometric function, of course, this you should know. Sin x integration is cos x, right? Cos x integration is minus, well, I think here you need to note that this integration of, because cos in differentiation is minus sign, right? So here I think minus sign is this is minus here, okay? So here this is a minus sign, remember. Cos x integration is sin x, right? Secant square x is tan x. Cosecant square x is minus cot x. Secant x tan x is secant x. Cosecant x cot x is minus cosecant x. Okay, so all this formula we have to remember, right? Because it is going to be useful. Some of this formula you can remember because of differentiation is opposite of integration, right? But some of the formulas purely you have to remember, nothing you can do. For example, here if you see this cot x integration, log sin, log means this base is e, you can say ln sin x, okay? And similarly tan x dx is minus ln cos x. Mod, because log cannot be negative, that's why mod is put here. Secant x integration log secant x plus tan x. Cosecant x integration is log cosecant x minus cot x. There can be more than one formula for some of these that we will also see. So that's why this video is important, because all the formulas are covered in this. You don't have to look anywhere. Okay, all the formulas I have covered it. Then next, irrational functions. If you take 1 by root under 1 minus x square, integration is sin inverse x 1 by 1 plus x square is tan inverse x. 1 by mod of x root under 1 minus x square integration with respect to x is secant inverse x. Right? These irrational functions are given in the sine inverse or trigonometric inverse functions. Okay. Similarly, 1 by root under a square minus x square is sine inverse x square. Only thing is that if you keep 1, you will get the previous result, right? Minus root under a square, this is more general, right? So, a can be anything here. You can rearrange and directly you can write this answer. Okay. 1 by a square plus x square is 1 by a tan inverse x square. Okay. Similarly, minus 1 by a square plus x square. This is 1 by cot inverse x square. 1 by x root under x square minus a square is 1 by a secant inverse x square. Minus 1 by x root under x square minus a square in denominator will be 1 by a cosecant is inverse x square. So all these are inverse functions. Okay, there are more irrational root under 1 by root under x square plus. So you can see here in the denominator, this will come more in application in maths, but in physics sometimes it can come for very complicated portions. That's why you must know this, right? So here you can see this is like a irrational in the denominator, right? Root under x square plus a square, here x square minus 2. So this is ln odd of x plus root under x square plus a square plus c. Here same ln only x plus root under x square minus a square. Okay, this is bracket or now is closed. Then 1 by a square minus x square dx is 1 by 2a ln a plus x by a minus x. 1 by x square minus a square dx is 1 by 2a ln x minus a by x plus. All this we have to remember. Then root under a square minus x square or root under x. So this root is now in the numerator. Okay. So in this case, this formula you have to remember. Root under a square minus x square dx means 1x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus. Okay. Similarly, root under x square plus a square is x by 2 root under x square plus a square plus a square by 2 sine h inverse x by a plus c. This is hyperbolic function inverse. Okay. Root under x square minus a square dx is x by 2 root under x square minus a square minus a by 2 cos h inverse x by a plus. Okay, so all these functions are there. Then integration of exponential functions. Exponential e to power x is e to power x by ln a. Okay, e to power x integration is e to power x plus c. E to power x into sine bx dx is equal to e to power x by a square plus b square. A sin bx minus b cos bx. Although this can be derived, but you should remember it because derivation will take at least 3 to 4 minutes. In exam, it is important to save that. So better remember this. Okay. E to power x cos bx is e to power x by square plus b square b cos bx plus b sin bx plus. Okay. Log functions ln ax is x ln ax minus x plus. So ln x, that means a is going to be 1 here, you substitute a 1, then x can be taken as common here. So x ln x minus 1 plus ln x is square whole square x ln x whole square minus 2x ln x plus 2x plus. Now if base is different, a log base ax is x log base ax minus x by ln a plus. Okay. Now hyperbolic functions, sin hx dx is cos hx, cos hx is sin hx, tan hx is ln cos hx, cot hx is ln sin hx plus c, secant hx is tan inverse sin hx, cosecant hx is ln tan h x by 2 plus c. Okay. So these are important formulas which you must remember. Now we can discuss like how do we evaluate integration. Okay, so for definite integration, how do we evaluate? Some examples please. Okay, So let us take example. Suppose you have to integrate, let's say from 0 to 10 x square dx. Okay, you have to find this. How to solve this? So x square integration, you know, now the formula is important. This is x square x to the power n integration. So x to the power n integration, you x to the power n with respect to x is x to the power n plus 1 by n plus 1. This integration you remember. So this will become 2 plus 1 by 2 plus 1. And using a square bracket, we will write the limits. Okay. So after that, this is of course is going to be x cubed by 3, right? From 0 to 10. Now what we will do is we have to substitute this limit. One time we'll put upper limit tan cubed by 3 minus next time instead of x we put lower limit 0 to 5. So finally you will get tan cubed by 3 or 1000 by 3. This will be the answer. Okay. So this is how you have to evaluate the definite integration. Definite integration. This is called definite integration, right? Definite integration. Definite integration means you need to evaluate it. You need to substitute the values of upper limit minus lower limit after applying the formulas. Okay. Now we will see some properties that we will take up in the next session. I hope you have remembered all this formula and you need to write it to remember it. Okay.